Okay, guys, we're going to go ahead and get started here in a couple minutes. I posted the science article yesterday, so hopefully you got a chance to look that over. If not, that's okay. Okay, I'm going to go ahead and get started. Excuse me. So today we're going to look at two things. We're going to look at heat, and the other one is just about kind of parachutes and air. So the first one we're going to talk about is heat. So the article starts about what happens to frozen food when you take it out of the freezer and put it on the counter. You know, it says in a few hours it probably thaws. Heat transfers to the frozen food until the food reaches room temperature. And when the food is the same temperature as surrounding air, heat transfer stops. That's called equilibrium. So equilibrium is when all things are equal. That means the temperature of the food would be the same temperature as what the room is. So, you know, in the summer, whatever your house may be, anywhere probably between 70 to 80 degrees. And then when the food gets to that, it stops basically heating up. So the food and the temperature in the room are the same. That's called equilibrium. Okay, that might be an important concept to remember when all things are equal. Then it goes on to say, heat is a form of energy that's transformed from one object to another when there's a difference in temperature. Heat always travels from hotter spots to cooler unless energy is added to change the direction or flow. You know, some of you might have noticed too, if you live in an older house, the attic is always cooler and or the basement is cooler because the heat rises basically from the basement up to the attic, and it takes a while to get in the attic. And some of us don't even have heating in the attic, so it's just basically the heat has to go up from the bottom floor up to the top floor. That's why in the summer sometimes if you have a basement, it's cooler down there because the heat escapes and it moves up higher in the house. So it says there's two ways heat can travel: by electromagnetic radiation, as in sunlight. So a lot of us know if we're in the sun, we get warm, or by conduction through material or any type, or by convention of a liquid or a gas. And that diagram right there talks about basically these two ways. So you see the electromagnetic radiation, that's from the sun. Obviously, the sun gives off heat basically. Even when it's cloudy, the heat is still coming through the clouds. So, and it's carried by invisible rays called infrared rays. That's how we get the sunburn. Infrared rays can burn us. That's why we try to, you know, sunblock or, you know, get a shirt on, because those those infrared rays are really strong and powerful. And the second two ways are, well, conduction is one, and heat travels by contact between a hot object and a cooler object. So when you put a pan on the stove, it's cool, but you turn the stove on, the stove starts to warm up, and then the pan warms up. And obviously if there's water in there, the water will start to boil. And that's the heat going from the stove to the pan and the water. And the last one is convection. And that's when hot air rises and cool air moves in to take its place. And that looks like kind of like a radiator there, like a radiator. Of the heat would come out into the room and it would slowly move up through the house and cold air replaces it. So those are the three ways heat transfers. So then we have two questions at the bottom. This is just going to review kind of what we talked about. And it says, what kitchen items cook food mainly by conduction? Is it a frying pan or a microwave oven? And it would be the frying pan, what we have right in the middle right there. Heat travels by contact between a hot object, which is the stove, and a cooler object, which would be the pan. And eventually the pan heats up and your food cooks. So that would be conduction, okay? The second one, pulling down a window and shades on a summer afternoon helps keep the house cooler by slowing heat transfer through. And that would be the electromagnetic radiation because you're blocking the sun out. So some of you, if you have houses and your house faces east, obviously the sun rises in the east. So in the morning, if you're closing your shades, you're blocking the sunlight from coming into your house. And that'll really keep your house cool. And basically, anytime we block the sun, you're slowing down the electromagnetic radiation, okay? And same thing, if your house faces west in the afternoon, if you close your shades, the sun's not getting in your house because you're blocking it because it's setting in the west. And that way you're preventing the sunlight from coming in. The sunlight does the electromagnetic radiation. So that's just a couple facts that you need to know about maybe heat, temperature, and equilibrium. That's kind of a key term. We covered that in class. So I'm going to move on to the next one. And this is one about, we did one about the plane last week, and this one's kind of similar. It says, why do parachutes collapse sometimes? Okay, so this gives you a diagram. It shows like when you jump out of the plane, parachute is basically all bunched up. But as you jump out, air comes up and inflates the parachute and it slows you down. But one thing that happens sometimes, there's called turbulence. And some of you have been in a plane when that happens. It gets really bumpy. That's when the air pressure is greater on top of the plane and it makes the ride really bumpy. The same concept happens with this parachute. So we'll go ahead and read this and we'll answer the questions. So it says when a parachute comes out of its container, its shape changes from a log to a streamer to a half cup in a matter of seconds. So the log would be kind of all bunched up, and then it basically goes to like a half cup, and that's when it's round. That's when basically you start slowing down, okay? The flow of air in and around the chute changes during the various phases of the flight. When the parachute first opens, it captures air, creating greater pressure inside the parachute than above it. So basically there's going to be more air blowing into the chute, and that's why it causes it to open, and that kind of slows you down a little bit. That's when people, you know, when you skydive, use a parachute, at first you're going really fast until the chute opens and all the air shoots up and basically the parachute expands. It turns into like that kind of a half cup, and that slows you down. It causes drag, and we talked about that with the airplane. So the chute is causing drag, so it's slowing the air down, so you're not traveling as fast. That says by the time the parachute is fully open, a great deal of energy has been transferred to the air. This creates a wake of downward moving turbulent air above the chute. As the parachute slows, air from the wake can push the chute and make it collapse. This also happens with some lump parachutes made of light, new synthetic fabrics. The large area gives the chute great braking power, but sometimes the air rushes around the edge of the chute over the top, collapsing it. And that's the turbulence I was talking about in a plane. So sometimes the air can get over the side of the actual parachute. It'll push the parachute in, and you can look at the third picture. Sometimes that can collapse the parachute. Okay, and then you'll start traveling faster until you get out of that turbulence. Okay, same thing like I mentioned on a plane. When you're in turbulence, it doesn't stay bumpy forever. Sometimes the plane has to go a little bit higher or a little bit lower to get out of that wind pushing down on the plane. And once you get out of that air pushing down on the plane, the ride gets smooth again. And the same thing happens with the parachute. Maybe you start going a little bit lower. There's not as much turbulence pushing down on the chute, and the chute will basically expand to where it was when you first jumped out that half cone. Okay, so basically, number one, why do parachutes slow a person's or object's descent? Okay, and that would basically be because of the air pressure. So what it says is, let me see here exactly how it's worded. It says the chute traps air, increasing air pressure inside, creating a drag to slow the parachute. So when that parachute opens, it basically is slowing the air from going up, and it creates a drag. Like the cloth basically slows the air down. And that's why when you jump out of a plane, as soon as the chute opens, you start traveling a little bit slower, because that big chute is causing drag. The air is getting trapped in the cloth or whatever the parachute is, causing you to slow down. Okay. And the second one says, why do parachutes sometimes collapse? That's because sometimes the air, you'll hit turbulence and the air pressure is greater above the parachute, just like in a plane. Sometimes the air is pressing down on the plane and you're getting turbulence. So, and sometimes the air rushes around the parachute, gets on top of it and starts pushing it down. But as you keep traveling, that air pressure will level out and the turbulence will stop and the parachute will expand again. Okay. So the second one, sometimes they collapse just because the air above the parachute has more pressure than the air inside, especially when the chute has a turbulent wake, and the wake can push the parachute down. So when the air pressure is greater, sometimes on top, it'll cause the parachute to partially collapse. Eventually, it'll come back up, just like in a plane. When you go through those turbulence, the wind is pushing down on the plane. It doesn't stay that way for a long time. Sometimes it's a couple minutes. Sometimes it's maybe just 30 seconds. That's when the plane ride gets really bumpy. And the same thing, kind of the concept with the parachute. Sometimes the air pressure is pushing down on top of the chute. It'll cause the chute to collapse and you kind of hit turbulence. Okay. So today, the takeaway, you guys, is just remember that the equilibrium, all things are equal. That's something that might come up on the test. And then just know heat transfer, there's kind of three ways. The sun, and that's the electromagnetic radiation. Conduction, that's when one thing goes from one to another, like a pan. So it goes from the hot burner into the pan. And the third is convection. That's when hot air rises, and that can come out of your radiator, your heat duct, or whatever. And that hot air is going to go up, and cool air comes and replaces it. Okay, so those are just the three ways basically heat is transferred. You can just refer to kind of that diagram, and that will really, really give you a better idea about the three ways that heat is transferred. And the second one about the parachute, just know that anytime there's like a piece of material, it's causing drag, like the cloth of the parachute is causing the air to slow down. But sometimes temporarily, the pressure above the parachute is greater. It'll cause the parachute to temporarily collapse, but eventually it evens out. And just like you can think of, the parachute is just basically slowing the air down. And I guess the concept, I mentioned this the other day, if you're driving and stick your arm out the window, you can feel the wind pushing against your arm. It'll push your arm back, but basically, you know, you're kind of slowing down a little bit the car because your arm is causing a drag when you put it out the window. Okay, so that's all I got for science today. I will post another science lesson tomorrow, another reading, and hopefully you can read that before we start our live science class on Thursday. I'm going to go ahead and send the social studies link here shortly, and we'll start social studies about 11 o'clock. Okay, you guys, have a good day.